All right, going to continue on doing some more of this final exam review guide for VISTAMAR 2025. In the other two videos, part one and part two, we did geometry, which included quadrilaterals, polygons, and diagrams, I'll say, with the patterns we're supposed to look for, like parallel lines. And we also did centroids in that first video, which includes circumcenters, perpendicular bisectors, things like that. In the second video, it was parametrics and linear equations. This video, the third video, it's just going to be everything else. This first one is vectors. I've got a vector note sheet right here, which is available at the link in the description. If it's not in the description, read the comments. So I'm surprised there's not more vector questions. It looks like this is the only one. So triangle PQR is defined by these two vectors, tail to tail. And the vector has two parts. It has the head and the tail. So I guess the start and the end. So these ones say tail to tail, so they're both starting at the origin and pointing outward. Find the area of the triangle PQR. You can see that's the same kind of orientation that's in our notes, tail to tail. And these form a triangle. And we have the formula to get the area of that triangle. So let's see, and here's our formula. All right, I'm glad I paused to do that because I was like confusing myself trying to plug in these x1, y1, x2, y2 into the right spots. It's x1, y2, but then x2, y1. Had to be extra careful. Guess we should watch out for those negative signs. So forget there's a subtraction right there. Subtraction. Negative 2 times 1. Busy work, busy work, busy work. Absolute value. And I got 7. I look at it and go, yeah, it looks like there's maybe 7 full squares in there. I guess I should be careful and see if there's any units in this one. I don't see any units. I guess if I wanted to, I could put units squared for area. The length of the shortest altitude in simplest radical form. Before going into that question, we've got the second formula. Oh, it's got a mistake on it for parallelograms. So the parallelogram formed from the vectors looks like that. It's basically, if you want to generate it accurately, you'd copy this vector. So you'd go 4 over 1 up, 4 over 1 up to make a parallelogram. And if you want the area of the parallelogram, it's pretty obvious. You just double it, or just don't do the 1/2. Then on to B. So we've got altitudes, the shortest altitude. The altitude is something that's perpendicular to a base and goes through a vertex. So perpendicular to a base and goes to the vertex. So this is one altitude, I guess the line. The other ones are hard to draw. Luckily, this is the one we're after. It's the shortest altitude. Take some practice. The line that's perpendicular to this base and goes through that vertex is not even inside the triangle. So you try and draw it, but these are all perpendicular, but it's not going through that vertex. I need to get over there more. So you're actually allowed to, and you have to, extend that line to draw that perpendicular. So this little length right here is that altitude. The other altitude would be this one. All right, but we only need the shortest one. All right, length of the altitude. So this is kind of along part B, the length of this altitude. To find the length, we're going to need to do the distance formula. And find this point, we're going to have to actually generate the equation of this line. And it's not through the midpoint. It kind of looks like the midpoint. the altitude is perpendicular to the base and goes to the vertex. So we're going to have to generate the equation of this line, then get the intersection of this line. Eek. For this line QR, I could do y2 minus y1, but I prefer just to count it out. So from here it's down 2, I'm counting my slope, and then over 1, 2, 3, 4, 5, 6. So my slope there is negative 1/3. I think I'll use point slope in this one. So this point is negative 2, 3. So y minus 3 equals negative 1/3 x minus minus 2. Now I need the equation for my altitude. I know it's definitely going to have a perpendicular slope. So it's going to be positive 3. I'm going to use point slope again. I don't know this point. In fact, that's what I'm looking for. But I do know the vertex is at 0, 0. All right, let me simplify, and then I'm going to do substitution or elimination to find that intersection. Now, there's probably a quicker way. There is a quicker way, but I'm just going to keep going with this. I'm going to solve this first equation for y. 1/3 x. So now I need to subtract 3, which is negative 9 over 3. Or I could just turn this into a decimal, which is negative 11 over 3. Now this equation, I also need to just get it the y alone. Luckily it's just 0, so it's y equals 3x. So now I'm going to look for that intersection, so I set these equal. And you first look at that and, oh man, it's got a bunch of fractions, yuck. You could just add 1/3 to the left side, but I think I'm going to kill off all these fractions first by multiplying through by 3, which is the denominator. So multiply this by 3, multiply this by 3, multiply this by 3, and now those fractions are all gone. Okay, add x to both sides. Add that x, then divide by 10. So I've got the x coordinate of this. It doesn't look good though, because it should be positive. So I gotta go hunt for some mistake. Must be this one. Should be negative 3. Trying to go too quick. Oh man, I have to fix all this stuff. So I add 3, which becomes 9 over 3. So that's 7 over 3. That's positive 7 over 3, which makes this positive 7, which makes that positive 7. All right, now I'll look at it. 7/10 looks good. I also need the y coordinate, so I'm going to plug. Oh man, I forgot it. Oh, I just remembered how to do this the easy way. Hey, I'm already committed. Dang it. All right, don't do what I did. I'm going to finish the hard way, and then I'll go back and do the easy way. So I'll plug in, darn it. I'll plug in 7/10 back into one of the equations. This one looks easier. Okay, and now I need to do the distance formula from 0, 0 to my point 7, 7/10, 21/10. The distance formula is, I guess you write it in different ways. I'm going to say it's x2 minus x1, which is 0 squared, plus y2 minus y1, which is also again 0. And then I'll just plug that in the calculator, and I will skip that part. Okay, dang. All right, the easy way to do it is to remember, since we already have the area of the triangle as whatever we got before, 7 units, we know that area equals 1/2 base times height. So this would be the base, this would be the height, and the area is 7. So we're looking for that height. This equation will be solvable if only we have the length of this base. So let's see if we can get the length of that base. It looks like just a straight distance formula will give it to us. All right, so I did the old x2 minus x1 and y2 minus y1, square is square, root, busy work, busy work, busy work, root 40. Let me see if that seems about right. Yeah, this is bigger than 6 because it's bigger than root 36. Yeah, this looks believable. Looks a little bigger than 6. All right, back to my formula here. Now I can just plug this in, root 40, then I'll solve this thing. So first step would be to maybe multiply by 2 both sides to get rid of that 1/2. I've got 14 equals root 40 times h. And the next step is to divide by root 40. And let me punch that in my calculator just to see if it makes sense, because 14 over root 40, I can't tell. See, this thing looks like it should be about maybe 2.2 or something like that.
14 divided by the square root of 40 is approximately 2.2136.
All right, so we're good. So that was definitely the easier way, so remember that one. I just came back and verified, get the same answer with the hard way. All right, let's see, what about number C? It's the image triangle under the transformation. All right, that one sounds pretty easy. Let me erase this stuff. Before I erase that, let me go into my formula sheet, which I see has another error. This part of this formula sheet is describing the process for figuring out the altitude. And you can see it says to take the area of the triangle, it should have a 1/2 there. Oh, and then divide it by 1/2 d. Oh, so those 1/2s cancel. So actually that formula is correct. So sorry for the confusion. But another way to do it is just know that it's the area. You can use this formula. Like, you don't need this formula. If you just realize that if you know the area of the triangle, you can plug it in. And if you know the length of the base, you can plug that in as a number and then solve for h. We didn't use this in this one, but if you have 2 points and you want to turn them into a vector, for example, if you had like 1, 3 and 5, 2, these 2 points, and you wanted to know what vector this is, the vector is written like this, and it's the change in x, comma, the change in y. So this one looks like it would go over 4. Right, 5 minus 1 is 4. And then it's, well, we call that 12. And then it's up 9. So this is more complicated when you read all these symbols, but that's what's going on. If you have 2 points, you find the difference in the x's, you put all that together, and it becomes a vector. All right. So on to C. I'm going to use this graph over here. This is a transformation, and it just says you add 3 to all the x values, and you add -1 to all the y values. So this thing's going to move the whole shape to the right 3 and then down 1. I think I'll do both transformations at the same time. So this point is currently at -2, 3. But I'm going to move it to the right 3 and then down 1. And it's going to arrive right there. So it's going to be, I guess, Q prime for me. And then for point R, which is at 4, 1, I'm also just going to add 3 to the x coordinate and then move it down 1. So that's going to be my R prime. And last one, 3 over, down 1, p prime. So I've got this new triangle. It did not change shape or size. So therefore that was an isometry, which it says as long as it doesn't change size or shape or doesn't get stretched, then it's an isometry. And that includes rotations are allowed also, as long as it's like the same size. Are the areas equal? Yes, because both triangles are the same size and shape. All right, let's check this one out. Definitely these radicals just cancel right away because I'm just going to square both sides. I have to FOIL this out. This doesn't turn into x squared minus 4 or x squared plus 4. You have to FOIL it out. X minus 2, x minus 2. It's first times first. That one times that one. And then, oops, no, I don't like to go in that order. X times x, and then x times negative 2. And then this one, and then that one. Let's see, x squared minus 4x plus 4. And yes, I do have to square that out. You might be thinking, oh, well, since it's square root, can't I just like cancel that with these guys? You could if it was multiplied, but because it's plus, you can't. All right, so I'm going to FOIL these out the quick way. So this one's going to be y squared minus 2y plus 1 equals x squared minus 12x plus 36, and so on. All right, I think I just turned off the cursor. Sometimes kind of annoying. It seems like it's always flying around all the time. All right, and then it's just busy work to simplify this thing. Let's see these, but oh, I see a lot of cancellations though. That's nice. Oops. All right, so busy work. All the squareds cancel, leaving with just these x, y. I moved everything to one side, but I guess I probably want to just solve for y. Maybe it's not necessary. Let's just simplify the equation, so I guess we don't get an answer. We don't get a number answer, but that's the answer I got. What is the translation vector? Problem number 28. So I see this as one of those isometries. It looks like the same shape. So that means each one of these points was moved over by the same amount. So I'll just choose one point. Let's see, it was moved over 1, 2, 3, 4, 5 to the right. So the vector would be 5. 1, 2, 3 up. Make sure those signs are right. I guess I should check the direction too, because I'm just assuming it moves right. Maybe like this is the starting triangle and this is the ends. It could be the other way. Maybe this is the starting triangle. From ABC to KLM. Okay, so I just got to negate both of those. Is ABLK a parallelogram? ABLK. I'd say, yeah, it looks like a parallelogram. These do look parallel, and these look parallel. But I guess if I have to prove it, that these are parallel, I would say this is 2 and 3, and this is 2 and 3. So these have the same slope. Maybe I should write it like this. The slope of this line is down 3 and over 2. So it has a slope of negative 3, 2. And it doesn't matter if I use this as my starting point or this one. If I use this one, it's up 3, right? And then left 2, which is the same slope. But I'm interested in the slope of this one also. It's down 3 over 2. The slopes are the same, so they're parallel. And these ones, slopes are the same, so it's parallel. So I'll say both pairs, opposite sides, same slope. So parallel. Find the area of ABLK. if it's a rectangle, then I can just do this distance times that distance. So let's see, were those slopes negative reciprocals? Let's see. Down 1, 2, 3, and 1, 1, 2, 3, 4, 5. Okay, so they are not negative reciprocals. So I'll have to use that vector thing again. Let's see, let me go grab that from my formula sheet. All right, that's this one, area of the parallelogram. All right. Yeah, if you need to draw this on your formula sheet, which you're not allowed to have diagrams, just write it like this. Write this thing sideways with no arrow. And don't write any of this, and then just write the formula. I guess technically you're not writing a diagram, but you'll know that this kind of indicates a parallelogram. And then this, you should be okay to write that. All right, so these vectors, see, this one is negative 2, 3. For the vector that the x comes first. And this vector is 1, 2, 3, 4, 5. 1, 2, 3. Positive, positive. And then I can just punch it into this formula. x1, y2 minus x2 times y, see, I'm getting all confused, times y1. Yeah, double check that. I'm trying to rush, so probably made some mistakes somewhere already. Negative 2, 3, 5, 3. Okay. And no 1/2. That was a mistake. So it looks like I just get 21 units squared. So I'm going to do a little visual spot check on this and just see if it looks like there's 21 of these blocks. Approximately. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Close enough for me. I guess another way to estimate would be pretend it's a rectangle and say this is about, looks like about 3 and a little bit. This one's about 6 and a little bit. 6 times 3, 18. Yeah, that's close enough to 21. That's probably right. 31, this was definitely on your homework. This would, yeah, this could definitely be a test question. Find both points on the line x equals 10 that are 13 units away from 5, 6. You don't need real graph paper. You could just hand draw this thing, but x equals 10, it's like that. But maybe it is good to bring some graph paper with you to test day. 13 units away from 5, 6, 5, 6. So the 2 points are going to be like, this might be a point that's on this line that's 13 units away, and then there's going to be another one up there. And the secret is you're going to do the distance formula, and the secret is to fill in this partially. We know the x coordinate is 10, and then for the y coordinate we don't know. It's somewhere up here. We don't know what the y coordinate might be. This one is also 10 comma y. And from that, we'll set up the distance formula and set it equal to 13. So distance formula is x2 minus x1, 5 squared, plus y2 minus y1 squared. So I guess it's not a slam dunk. Got some work to do. Got to FOIL that out. Ooh. Yeah, but and I'll square both sides at the same time. Okay, I'm going to square both sides. 169 equals 25. FOIL that out. And then some quadratic busy work. So I just used my calculator to, okay, so I moved everything to one side. Now I'm about to factor this thing. I kind of used my calculator, look for numbers. That's not XY, just numbers that multiply to 108. So for me, I'd start by dividing it by 2 and I get 54. And I just did 108 divided by 3 on my calculator. And then just generate the other ones. But it looks like 6 and 18 will work. Of course, you could use Ben Quad or AA Quad programs on your calculator. So these are our two y values that create our 2 points. Thought this one looked easy, but it's a little bit tricky. It's a polygon problem, and they don't tell us how many sides. I mean, of course you should pause and look at this before you just keep watching this video. But to draw the polygon, the letters have to be in sequential order: A, B, C, D, E, F, G. And then they tell CAB is 12 degrees. When I first read it, I was like, how could that possibly be 12 degrees? But once you read it, the order of the letters means it's C, A, B. So it's this angle is 12 degrees. So let me blow up that triangle here, make it bigger. So if that's 12, we definitely know this is isosceles. And we saw some of this in the geometry section. When it's isosceles, these two angles are equal, leaving only this third angle for these three to add up to 180. 24 equals 180. So it's that 156. And then from there, that's the interior angle. We'll plug that into our interior angle equation for polygon interior angle. It's 180 times n minus 2 over n. So I'll multiply both sides by n to get rid of that denominator. Then I'll distribute this 180. And that looks pretty solvable. All right, so we get a 15-sided polygon. 33, a trapezoid. Trapezoid definition is it has two parallel sides. And the left side doesn't have to match the right side, which it doesn't in this case. They tell us it's got a 60 degree and a 45. And they're asking for these other two angles. Because it's a parallelogram, not a parallel, because the lines are parallel, these consecutive angles are supplementary. If you weren't sure about that, you could use the technique of extending the lines, and then you can see the two clusters. So this is 120, 60, 120, and then that mirrors up here. Everything's the same. 120, 60, 120, 60. So you can see the angle we're looking for is 120. So in this one, I won't draw the two clusters. I'll just know that they're supplementary. So it's 135. 45 plus x equals 180. X equals 135. 34. Easy one. Easiest question on the whole test. The sum of the exterior angles for any polygon is always 360. And if you look on our notes packet, you'll see somewhere in there, there's the formulas for like the sum of the exterior angles, the equation for an individual exterior angle, etc. But yeah, the sum of the exterior angles is 360, no matter the number of sides. For a square, it's 90 plus 90. Oops, plus 90 plus 90. Those are the exterior angles. And for a triangle, for example, that's this angle plus this angle plus this angle. Adds up to 360. All right, got some roots to simplify. So this one's going to break up into root 9 and root 2. So I get 3 root 2. This one's going to break up into root 9 and root 3. So what I'm doing is I'm looking for perfect squares that factor into this, like 2, 4, not 2, 4, 9, which is 2 squared, 3 squared, 4 squared, and 5 squared. All right, and then the perfect square, I can square root it. So this one, 100's another one. This one I'll break up into square root of 100 times square root of 3. You are allowed to divide between radicals. You're also allowed to multiply radicals. Like root 2 times root 3 is root 6. So here I'll simplify this fraction first. So it's going to be, they're both divisible by 2. And then I need to rationalize. So I'll multiply by root 3 over root 3. This one, pretty hard. Let's see, but it is divisible by 4. So it's root 4 times root 13. 2 root 13. So this one, you simplify this one. It breaks up into root 4 and root 2. So it's 3 root 2 minus 2 root 2. Since these match, it's 3 minus 2 is 1 root 2, or just root 2. So a perfect square trinomial just means it factors. They all probably factor into two things like that, but if it's a perfect square, they're identical. And there's another faster way to look at those, but I'll just factor them all. So two numbers that multiply to 6 and add to 5. Okay, it factors, but it's not perfect square. This one looks promising. X plus 3 and x plus 3, right? Two numbers that multiply to 9 but add to 6. Yep, I think B. But let's keep checking. C looks promising also. Let's see, two numbers that multiply to 16 but add to negative 8. Seems like it'd be x minus 4, x minus 4. So I've got two answers that seem like they're right. And that one's definitely out. All right, did I make a mistake? Let me look at those for a second. Well, that's annoying. They both look right to me, but I can't tell if you're allowed to have more than one answer. So it seems like they're both right. So a 30, 60, 90 triangle has these ratios. Multiply by 2 and then root 3. That's the way I write it. You've probably seen it. I guess these are other common ways to write it. But I'm going to do it the way I like. Hypotenuse of length 4. So I know it's, my little diagram says to get the smaller side I divide by 2. And then if I want that side I have to multiply by root 3. And then I'll just rinse and repeat. So 9 divide by 2 and then multiply by root 3. For that one, divide by 2 and then multiply by root 3. The right isosceles triangle has a hypotenuse of length A. A right isosceles triangle means these two are equal and this is right. And that necessarily makes it a 45, 45, 90. If you're not sure, you can calculate those. X and X. 2x plus 90 equals 180. For a 45, 45, 90, the ratio is just root 2. And these two legs are identical. Did I say isosceles? This is true for a 45, 45, 90 triangle only. All right, let's check it out. So they said if the hypotenuse is 4, then I just divide by root 2. 4 over root 2. Rationalize. We get 4 root 2 over 2, or 2 root 2. Those will be the same. For 9, I divide by root 2. And then I have to rationalize again. So I get 9 root 2 over 2. And if it's root 2 divided by root 2, it's kind of nice. It just turns into 1. 1 and 1. Just make sure that's what they're asking. Yep. 41. Write a true statement that has a true converse. Write a true statement that has a false converse. True one, let's go if it's Sunday, then tomorrow is Monday. And the converse of that would be if tomorrow is Monday, then today is Sunday, which is true. So that's my true one. And here's a not true one. Let's see. Or, well, it's true if it's a true statement where the converse is not true. If it's the 31st of the month, then tomorrow is the 1st. Because there's no month with 32 days in the calendar, right? But then let me try the converse. If tomorrow is the 1st, then it says tomorrow. Then today is the 31st, which is not true because it might be February 28th. All right. All right. Looks like I skipped 36. I don't remember you guys doing this either, but let me read this off. There's a point 4,2 and something about equidistant between this point and the y-axis, which I've dashed in as a directrix. I don't think you guys studied this, so you shouldn't have heard that word before, but it's part of parabolas. So I don't know if you can tell because I don't think you guys had this before. This is a parabola problem. One definition of a parabola, parabola, quadratic. One way to define it is the set of all points that are equidistant between a focus and a line called a directrix. I don't know how much you want to get into this. Maybe I'm wrong. Maybe you did have it. So for example, like this point, it's equidistant to the directrix and the focus, and maybe I'll just pick some other random point. Like this point is, I didn't draw it perfectly, is about the same distance from this point and the directrix. If I go further away, it'd be this distance and this distance are the same. Yes, this distance is the shortest distance, so it's not measured like that. It has to be directly towards the point. Let's see, so we've got 4, 2, we've got a point x, y, and some other point, which is 0, y. So one way to do this is do the distance formula here and the distance formula there, and then you set them equal, and it'll give you that equation. But if you have this topic, you'll know that the vertex is going to be halfway between the directrix and the focus, so it's going to be 2, 2. Vertex is 2, 2. And in this case, P is 2. There's different formulas for a parabola. What's this one? Y. I'm gonna use this one. So 1 over 4p times, I guess I reverse these. Now, if you don't recognize this, then you have to use the other thing I was talking about. Get an expression for those distances and set them equal. But I'm going to use this. So h and k are my vertex. So it's x minus 2 and p is 2. That's 1 over 8. And I don't even have to FOIL this. I can just leave it like that. Should I do the other method? Nah, I don't think you guys can have this, but I'll set it up a little bit. So it's y minus 2 squared plus x minus 4 squared is going to equal y minus y squared x minus 0 squared. So let's see. So those are going to cancel because I'm going to square both sides. And then busy work from there. Cancels. Yeah, then I guess I'll just solve for x at that point. Yeah, I wouldn't worry about this. So I'm just doing this, I don't know, just for the sake of being totally complete. But I don't think you guys had either of these topics. I don't know, put it in the comments if you did, or send me an email. So I'll just move all this stuff to the other side. In fact, I'll just move this to the right side. 8x equals y squared minus 4y plus 20. And then multiply by 1/8. So I'll just leave it like that. Yeah. I don't know, different forms, but same equation. All right.